Welcome to the final video for 9-7. Next we're going to do piecewise defined functions. It turned out that step functions were actually a form of a piecewise function. Basically, a piecewise function is anytime you have to pick up your pencil to draw the graph, that means it has different pieces, so it's a piecewise function. So, there's kind of a picture of an example there. You can see how it has the two different segments, one down here, one up there. Let's go ahead and try one. Look at all that beautiful math we've done already. Here we go, piecewise defined function. Here's how it looks when they actually give you one. The function equals, and then there's this bracket with a whole bunch of information behind it. Here's what I like to do. I like to recognize the fact that each of these is actually its own function like that. So it helps me to rewrite those. And by the way, I don't like f of x. I'm going to write that as y. Y equals negative 2x. Put a big space and then the word if. X is greater than 1. Y equals x plus 3, big space if x is less than or equal to 1. The reason I like to big space that is because for just a minute, I take my finger and I cover up this stuff so I can't see it, okay? Pretend it doesn't exist. I know how to graph that. That's easy. That's y equals mx plus b. Now I'm going to graph it. I'm on the computer or on the tablet, but if I was doing this by hand, I would just do it in light pencil because I'm going to end up erasing part of this. But y equals negative 2x. That means my y-intercept is at 0. And then negative 2 over 1. So down 2 over 1, down 2 over 1. Going the opposite direction would be up 2, left 1, up 2, left 1. And I'm kind of thinking in my head, okay, so these are going to connect like that, kind of, sort of. Now what I'm going to do is now I'm going to come back and say, okay, I recognize the fact that that exists, so now I come back and look at it. It says if x is greater than 1. The key is that it says x is greater than 1. So look at your graph, go to where it is x is 1, so right here, right? Go down to the graph. You're going to have to remember your circles and dots. Extra ink, extra ink. So I go down from the x is 1 to where the graph is, and I'm going to put a circle, not a dot, on the line. And then, here we go, there we go, that'll work. So I'm going to erase that part here. Then what I'll do after that is it says x is greater than 1. So the x numbers that are bigger than 1 would be these ones all right here, right? So that means all of this section is the part of the graph that I want to keep. Everything on the other side of this circle, I'm going to be erasing. So I take my eraser and down I go. And then I'm going to take my pen and go ahead and draw an arrow on the rest of that. Now that was just taking care of the first function. I need to come back in and do this one now. And I start off doing the same thing, ignoring the if part, and just graph the x plus 3 like normal. Up 3 would be my intercept, and since there's not a number written in front of the x, I know that it's just 1, which means my slope is up 1 over 1, up 1 over 1. Down 1 left, 1 down, 1 left, 1 down, 1 left, 1 down, 1 left, 1 down, 1 left, 1. And I'm going to go ahead and connect those. But again, it says if x is less than or equal to 1. So I come over here to the 1 spot, travel upwards to the graph, and I ask myself, is this one a circle or a dot? This time it's a dot, so I'm going to draw a big fat dot right there. And it says x is less than 1. That means I want the numbers that are smaller than 1. Those are the ones I'm going to keep. Anything to the right gets erased. Like that. Now that I have graphed both parts of this, the top graph and the bottom graph, that's my final answer. I'm going to do another example. I want to do one where it has 3. That one only has 2. Oh, we don't have one where it has 3? Well, I'll see if there's any on your homework, and I'll make another video if we need it.